So here. So what we had done yesterday, we talked about how since this doesn't cross the x-axis, that we had what I had you write initially, because we're going to add to this here in a second. But since this doesn't cross the x-axis, we said that there were no there were no x-intercepts. And what that meant, there was 0 real solutions. And we kept throwing around the word real. Today, that'll become a little bit more important. But right now, there are no real solutions to this problem. When we went through all this work, we ended up getting a standard form of x squared plus 4x plus 2. So you should already have that on your paper. And then what I wanted you to do, if possible, was then factor the standard form. But then what we had just kind of finished with at the end of the period yesterday, there are no numbers that multiply to be 2 that could be added up to give you a 4. So that doesn't get factored. It can't be factored. So what we then instead said, if it couldn't be factored, what I wanted you to do is the quadratic formula. So for this space here, we want to solve this problem using the quadratic formula since it doesn't factor. So the quadratic formula, again, I don't have to write it all, I don't think. Here's our b, it's a 4. So the opposite of b would be a negative 4. And then plus or minus our square root of b squared. So b is again the 4. Minus 4 times a. A would be the 1 that's in front of our square term here. And then the c is the constant 2 that's hanging out at the end. And then all divided by 2 times a, with the a being a 1. Then we're going to go through, clean that up. Square root of 4, or square of 4 is 16. Yes. Oh, crap, maybe it is. Yeah, good call. Yeah. You're right, it's a 5. Thank you. Yeah, good call. Come on, you. So then this c is a 5 here. So then we get minus 20. Yeah, I guess you would have figured that out next one here. And then 2 times 1 is a 2. So what we now end up with is a negative 4 plus or minus the square root of, and then now look at what we get underneath. When I do a 16 minus a 20, we finally legitimately get something that I've been telling you for the last few weeks that we don't want to get. And that is a negative number underneath our radical. I've been saying all along, if you get a negative number underneath there, you messed up. Go back and look at it. We shouldn't be getting any negatives until now. So then the question is, what does that mean? How does that evaluate? Can we do the square root of a negative 4? So if I go to our calculator, let me clear this out before you can see it too quickly. Let's see what our calculator will tell us about the square root of a negative number. So if I try to plug this into my calculator right now, and I hit enter, notice what it says, that we have an error. But notice also what it says here. We have answers. We've been writing real the last day. This is saying we have answers, but they are considered non-real answers. Okay? So that's important to understand. We want to identify that there are solutions to this, but they are what we call non-real solutions. All right. So what we're going to do with this, come down here, and this is now number 5. Number 5 is asking, Israel was concerned about his factored form in question number 4 because it did not look right. So that's alluding to the fact that it has a negative number underneath the radical. So why might Israel be concerned about writing a factored form in number 4? And it's because of this. So what we're going to write here for this 5th question is we got a negative number under the radical. That means we don't have any real solutions, but we do have something called non-real solutions as long as we trust what our calculator is telling us, okay? So when this says what happens when we have a negative number underneath a radical, what you're going to put in here is we get non-real solutions. What do we call non-real solutions? We actually could write that. That's not necessarily wrong. If somebody told me there's two non-real solutions, but what they're typically referred to if they're not real, then we call them imaginary. All right, so two non-real solutions is the same as saying that we have imaginary solutions, and there is an imaginary number. Okay, so what we're going to put for our definition, we're going to write a few things here. They're called complex numbers. This is a number set that you guys have never really discussed before when you put it on rationals, integers, irrational, all those things, natural. They're complex numbers. The reason they're called a complex number is because we're going to take a real number, like a number that we actually know, a real number that we can plot on a number line, and it's going to get multiplied by the, and then here's the big part, the imaginary unit. So whenever we talk about an imaginary number, the imaginary unit, and what that looks like is the letter I. Okay, it's a little small for those in here. Let me make that bigger. So the imaginary unit is the letter I. If I go back to my calculator now, this is telling us we could not do that. If I go to my mode, you don't necessarily need to know this or show this, but if I go down to here, can you see that on the board yet? Notice how it's flashing real numbers. Let's say I move over. See how there's a little I right here? That's our imaginary number set that we can now start working with. If I go to that mode and come back over and I now plug in the square root of a -4 again, now that it's going to allow our imaginary set, look at what this will tell us our answer is. Notice how it's a real number 2. 2 is a real number, and it gets multiplied by the imaginary unit I. Okay? So, what we also want to write down here now, we're going to write a couple of things, but one of the things you're going to write is that when we take the square root of a -1, that gives us the imaginary unit, the letter I. It's another thing I want you to write down. So how does that then relate to the problem that we were actually trying to solve a minute ago? So let's go back to number 4, and let's now finish this the way that in the future I would expect you to finish this. Okay? So we now know that we can handle this. So we want to go ahead and do this final step. We're going to take our -4, just like we would have before, plus or minus. The way we're going to handle what I have shaded here, that root -4, is we're going to make 2 different square roots. We're going to put the regular old 4 here, and then we're going to do a -1 right there. Hopefully we all agree 4 times a -1 is a -4. And then we're still going to divide that by a 2. So here's where the calculator gets the weird 2i from. The -4 doesn't change. But don't we know the square root of 4 to be a 2? And what we now know is whenever we do the square root of a -1, that is the letter I. And then all of that divided by a 2. So when we now start getting these negative numbers underneath the radical, which you are now going to get, that's how we now have to clean that up with the imaginary unit I. Now come back up to here. Notice how we said there are no x-intercepts. That means there are 0 real solutions. But what we now know is there are 2, and the reason there's 2 is because we could add the 2i or subtract the 2i. There are 2 imaginary solutions. Okay? Then, one other thing that I want you to write underneath where we have the definition for imaginary solutions. So this second thing, so let me do it over here. Make this big for everybody. All right, recall how if I gave you like a root 3 times a root 5, as long as these are, you don't necessarily write this part down, but if I'm multiplying and they're both underneath the radical, we said we can go ahead and multiply those to get a root 15, perfectly legal, okay? So that's possible. So what I want you to now do for the second thing that we want to understand, let's say I take a root -1. I want you to then say that you're going to multiply it by another root negative 1. Because that we can do, right? Since they're both underneath the radical, can't we now do a negative 1, multiply it by a negative 1, and that turns into a positive 1? And then can we do the square root of 1? Yeah, and that should give us a 1. The reason I want you to now do that, and hopefully you left a little space underneath there, so I kind of deliberately left this space. Remember how we just said this guy here can be written as an I? So the negative root, or root negative 1 is an I. I'm going to multiply that by another root negative 1, which is an I. So just think, what's I times I? That should be I squared. But when I write it like this, it equals I squared. When I actually use the radicals, it equals 1. So what that would then have to mean is that, and write this down, I squared would have to equal a 1. Because it's really a negative root 1, or root negative 1 times another root negative 1. So the two big things to make sure we understand about imaginary units, and it should be enough for you to get through these next few days, is that the square root of a negative 1 is called I. And if I take two i's and multiply them together, that's got to be equivalent to a 1. Okay, and those are the things that we want to make sure that we're squared away on. All right. All right, so this we've already done. Let's look at our solution in question number 4. We've already gone back and rewritten that. So that is this version here, where we now have a negative 4 plus or minus 2i, all divided by 2. Okay. All right, so now let's make sure we have that part down. So go to numbers 1 through 4. And all I want you to do here is simplify each of the following expressions. So the way we're going to do this root negative 4, we don't really want a negative underneath that radical, at least with our number. So we're going to write this as a product of 4 and a negative 1. Because 4 times a negative 1 is still going to give you a negative 4. Each of those now we know how to handle. The square root of 4, you've known for a very long time now how to handle that. That's a 2. And then we now know whenever we get this square root of a negative 1, the square root of that negative 1 is where the imaginary unit I comes in. So that is written as 2i. So 2, pretty much the same thing. We're going to take 16, multiply it by the negative 1. And then we can do both of those now. The square root of 16, we know that to be a 4. And then the whole new idea of the day is when I do the square root of a negative 1, that's our imaginary unit I. Now, you guys in the class can't see this. This is a negative, though. You can see it on your paper, I suppose, but that's our negative 12. So similar, except these aren't, like numbers 1, when you look at a 4 and a 16, those are nice perfect squares, so they work out nicely. A 12 is not. So the way we're going to do this, same way we would have before with the 12, we're going to write this as a 4 and a 3, because that gives us a 12. And then the 4 is our perfect square. But now that that negative is there, we're going to add in a third factor. That's a negative 1. So you could check, if I did 4 times 3 times a negative 1, that's going to give us this negative 12, correct? So it's the same exact thing, just written out a little bit differently. Because now I can do the square root of 4, that's a 2. The square root of 3, we can't do anything with that, so I'm going to just leave that alone, square root of 3, like we normally do. And then now when we approach this root negative 1, we know that is an I. And since it's no longer underneath the radical, we're going to put it out in front. Somebody asked last period, and actually it does get written like this sometimes. If you just go ahead and put the I behind this, that's okay. Just make very, very clear that it doesn't belong underneath that radical. You have to make sure that it doesn't belong underneath there. So you might want to put a little dot here to say it's a 2 root 3 and then multiplied by our I. But I would prefer if we just take the I, since it's not underneath the radical, put it out in front with your 2. Okay? All right, so last one real quick. Do number 4. See if we can simplify that now using our imaginary unit I. So do the 50 normally, like we've been doing a root 50 for a while, simplifying that. And then now we just have to understand how to handle the negative part. All right, so if I had given you 50, something we've been doing for a while, hopefully we understood I would use 25 and 2 to get the 50, and the 25 is our perfect square. But now that we have the negative, we're going to go ahead and write the -1 as our third factor. All those together give us that -50, just like the previous 3. You have a perfect square here, that's a 5. The square root of 2, you can't do anything with this, so we just have to leave it as a root 2. And then again, walk out of here today. If you understand that the root -1 is now I, then you've caught the main part of the day. All right, so that root -1 then is I. Okay? Okay, so now, next thing, filling in this table here. If you ever hear the expression, the discriminants, so if I ever say that, if you ever see this, what the discriminant refers to is this expression right here, which should look familiar to us. When we've done the quadratic formula for the last couple of weeks, we use that to solve our equation. So here's the quadratic formula. The discriminant is simply the number underneath your radical. That's all we are referring to when we talk about the discriminant, is what kind of a number do we get underneath there. And the reason that is important, it's going to allow us to determine the number of solutions and the type of solutions to our equation. Are they imaginary? Are they real? Do we get 2 solutions? Do we get 1 solution? Do we get no solutions, or at least no real solutions? Okay. So in your table, what you're going to fill out, there are 4 things that could happen. So in option number 4, we're just going to write what the discriminant is. And the radical isn't even necessarily part of it, but I like putting it there. One of the things that could happen is we could get a positive number. And then actually I'm going to have you do the same thing I did last period. Go to outcome number 2 and write the same exact thing. Is when we evaluate this, we could take the square root of a positive number. But there are 2 types of positive numbers we could get. If we end up with a positive number that is a perfect square, then we're going to get 2 real and rational solutions. Basically, we get nice numbers like 6, -4. We don't get the weird radicals in our answer. All right, so if that's our combination, we know we get 2 real rational solutions. However, we could also end up with a positive number that is a non-perfect square. That means we're still going to get 2 real answers, so 2 real solutions. However, these are the ugly ones that we've been doing, where we get those radicals in our final answer, and those are our irrational. So we get 2 real irrational solutions. So if we get a positive number underneath our radical, we're going to get 2 real numbers. The question is, are they nice numbers or are they not nice numbers? All right. If it's a perfect square, we get nice numbers. If it's not a perfect square, you're going to get the radicals, the irrational numbers. The third thing that could happen. So do your b² minus 4ac. we could end up with a value of 0. So if the number underneath our radical becomes a 0, what that means is we only get one real and rational solution. That happened yesterday. We're going to confirm that now with our discriminant, but that's how you can only get one real number if you get a 0 underneath there. Fourth and final thing that can happen is what we just did in the previous problem. I could end up getting a square root of a negative number. So what I've been telling you we shouldn't be getting, now that we can get those, if that happens, what that means is we get 0 real solutions. Oops. But that means we get 2 imaginary solutions. Okay. And then whether you understood, you probably didn't when we were doing them yesterday. These are the 4 different problems that we dealt with yesterday, but we didn't do them in this fashion. So what the next question is now asking us to do is go back to those previous 4 questions and now kind of confirm what these outcomes were. So for number 1, so underneath here, look back at problems 1 through 4. So if we went back to problem number 1, here was our original function. Actually, I don't remember it again. Do you remember what it was? It was y equals x squared plus 4x. It should factor nicely. Plus 3. It had to be 3. Had to be 3. All right, so that was our problem in number 1. And by number 1, I'm talking about all the way back to the beginning of these notes, number 1. Okay, that's what we're talking about. Recall what we said in number 1. We have 2 solutions. So down here in letter C, I said we have 2 real solutions. And they were rational. We can just look at the graph and say what our solutions were, right? They were a -3 and a -1. Okay, so we know we get 2 rational real solutions. Well, let's say we didn't want to go through all that work. What the discriminant is giving us is a little shorter way to understand if we get real answers or not. So what I want you to do now in number 1, set up the discriminant. So set up basically just the part underneath the square root. Just this guy. And evaluate these. So I'm going to do the square root. We know our b is a 4, so we're going to do 4 squared, so that's 16. And then minus 4 times a, which is a 1, and then our c is a 3. As we clean this up, we end up with 16 minus a 12. And we ultimately end up with a positive number underneath there. So get to this step, because I'm going to move this here in a second. So notice how we get a positive 4 underneath our radical. If you go to the table above that we just filled out, if we get a positive, and then this is a nice perfect square, that's this here. If I do this discriminant and I get a nice positive perfect square number, we would get 2 real rational solutions, just like we found out when we did them the long way yesterday. There were the -3 and the -1. So that's what this is telling us. Okay. Now, number 2 yesterday. Here was the equation yesterday for number 2. And then I'm going to take you back to the graph. So write that equation down. That's a 4x plus a 4. Some sloppy handwriting going on there. So now let's go back to number 4 and see how many solutions we had to number 2. All right, so remember how this one only touched the x-axis one time? We said yesterday there's only one real and rational solution. That's it, there's only the one. So if we now do the quadratic formula with this, so here's our equation. Notice how we're only going to get one real solution if we get a 0 underneath our radical. So now watch what happens when we set this up. So if I set up my discriminant, b squared minus 4ac, our b is once again going to be this 4. So that's going to be 4 squared minus 4 times a times c. We better get a 0 out of this. If we only get one solution, that means our discriminant has a value of 0. So 4 squared is 16. If I do 4 times 4, that's another 16. I'm going to subtract those. Notice how we get a 0 right here. The graph confirmed this for us, but it's the same thing that we would have just filled out with our table. If we get a 0 underneath the radical, we would only end up with one real rational solution. And that's what we found yesterday when we did number 2. All right. All right, and then the last one that we now need to do, because we've already done the fourth one, number 3, here was your discriminant, x squared, or your equation, x squared plus 4x plus 5. Let me take you back to number 3 so we can see what we found yesterday when we did number 3. We had 2 solutions. So we know we have 2 real solutions when we did this. We weren't sure what they were. We had to do the quadratic formula, but what we did find is they were irrational. Okay, we've already done that. If you went back and look at your notes, we already did this. We did the quadratic formula. We found out what those were. But the discriminant should also tell us that we should get 2 irrational solutions. So set that up. So b squared minus 4ac. B is again the 4, and then times 4 times a of a 1, and then our c is now 5. Was it? Yeah, you might be right. Hold on a minute. That was a plus 2. That one was a plus 2. Yeah, thank you. Yeah, write this as our equation, sorry. So change this. Make sure this is a plus 2. 16. Yeah, because we'll get the 8 that way. All right, and then that should be our C. Simplify that. We get 16 minus an 8. So notice, we do get a positive number underneath here. So this is a positive 8. But if we go to what we wrote down in our table, if I get a positive number, but it's not a nice perfect square, then we get 2 real numbers, but they're irrational. And if we went back to number 3, that's definitely what we got. And that's because we got a positive number, but it was irrational. Number 4, we won't go all the way through it because we just talked about it. But in number 4, when we did all of this work, remember how we got a negative 4 underneath it? That's why we get these 2 imaginary solutions. Okay, so those are the 4 different things that can happen. We can get a nice perfect square, we can get a non-perfect square, we can get 0, or we can get a negative number. Okay? All right, so now, real quick, let me just show you what I want you to do for these homework. So go to your homework. What was it, 25? Yeah. All right, so pull out your homework packet real quick, page 25. So go to page 25. We're gonna do a couple, and I'll tell you what I want you to get done for tomorrow. All right, so on page 25, it's saying given the quadratic function or its graph, so like in number 10, you're given the function. In number 8 and 9, you're not given the function. All you're given is the graph. So whatever I give you, determine what type of x-intercepts we should have, and then explain or show how we know. So for number 8, I should be able to look at this graph. This is what we quizzed on last week. Notice how we're going to get 2 real solutions. It definitely crosses the x-axis. And then you would ask yourself, do those go through nice whole integer values where we don't have to guess, they're not decimals of any sort? And they are. We could actually answer this question. This is actually one similar that I gave you on the quiz earlier. Our answers are x is a -2 and x equals 3. So those are real numbers. and they are rational numbers. So we can do that by just looking at our graph. They cross the x-axis twice. We can identify what they are without guessing, so that means they have to be these nice rational numbers. Number 9 is now the new part. Notice how this graph doesn't cross the x-axis at all. So we would say we have 0 real solutions because we don't cross the x-axis ever. But what we now know, we would say that we have 2 what we call imaginary solutions. All right. So real quick, if you go down to number 11, same thing, right? Does number 11 hit the x-axis at all? No. So there are 0 real solutions, but we would say that we have a couple of imaginary. If we knew what that function was and we could set it up, we would get 2 imaginary solutions. Now, the last one that requires a little bit of work here, we get 2 solutions, so we definitely get 2 real solutions. But we don't necessarily know if these are real or rational or irrational. And it's because of this point right here, it's kind of hard to tell if that's definitely a decimal, and we wouldn't want to guess because that could be a rational decimal or an irrational decimal. So when that's the case, that's where we can use our discriminant. And so this is the one that requires a little bit of work. So I'll set this up real quick. Substitute our values in. Our b has to be 3, so 3 squared, minus 4 times a times c. A is a 2, c is a negative 5. So 3 squared is 9. If we multiply all these together, the negative 4 and 2 would make a negative 8. A negative 8 times a negative 5 is a positive 40. So the way we can now determine if these are rational or irrational here is by looking, is this a nice, perfect square? Right? Yeah, and it is. And since it is, that means they are rational answers. That's how we could determine that by using our discriminant. Okay? All right, so here is going to be your homework. You're going to be doing, this page, which was page 26, is actually where you, or is it 25? Page 25, I think. All right, here's your homework. You're doing numbers 12 through 22, and you're just going to do the evens. Okay, 12 through 22s with just the evens. Quadratic formula, determine if they're real, rational, irrational, okay, all that good stuff. All right? Okay.